thanks for being here, guys. We're going to spend a little time talking about an air handler, some of the temperature sensors, and how we can use analytics to first see if everything's working right, and then also use some other tools to calibrate those, make sure that the system has got the correct temperatures all the way through, from our return and outside air all the way through mixed air, discharge air, and so that we make sure that the system will sequence correctly so that we don't waste energy thinking we're at 55 degrees when really we're at 50 degrees or 52. And so want to spend a little time talking about that. We'll start first with some analytics. Now, have any of you had the chance to see some of the analytics that we've looked at over the last year? You have a little. The analytics we're hoping to add to all of the buildings eventually. So if you have a building that you're like, I'd really like this on it, then let us know and we'll put that on yours first instead of just going through the list. In this particular building, we've got the graphic for the air handler pulled up, which is what we're standing next to. What I'd like each of you to do before we even go any further is to come look at this graphic and see if you can identify a problem having to do with the temperature sensors. So we'll give you a minute to do that. So each of you take a shot at it.
Look at the temperatures, is that what you're saying?
Temperature sensors.
Yeah, see if there's something you can detect with the way, with the temperatures of the system.
By the settings, no?
By the layout on the graphic, by just looking at it. Does anything look odd or out of place? All right, so something doesn't look right. Casey pointed out we've got 72 before our chilled water coil, 72 or right after it, but then the fans have this amazing cooling effect now. We've got these new high-tech fans. They cooled it all the way down to 56 degrees, right? So, chilled water fans. So something's not right in that thing. The other thing we want to do is we want to first also go through and look and verify that we've got everything like it shows. There's a little bit of a misrepresentation in the graphic. We want also for you guys to see that so you understand it before we fix it. So when calibrating sensors, one of the things that you'll want to do is get your building or your air handler in a steady state, right? We don't want valves opening and shutting. This time of year, we've got to have cooling. So it's pretty hard to do the discharge side of this during this class because we don't want 70-degree air going down the duct, right? So what we're doing is we're going to leave our cooling coil going, but the best time for you to come and calibrate your sensors is in another couple weeks, maybe a month. We start hitting cool mornings where we've got 55, 60-degree mornings. And if you'll take and put full outside air, you can still keep the building comfortable and run all of your sensors so that they're calibrated. Does that make sense? Okay.
Just another way that we've done it in this situation is we've put data loggers in the air handler and then logged it with the computer over the course of a few days. And then we can actually see, if you trend them together, you see the temperature difference. And then we do a calibration, and then we do it again for 3 days to see if they've actually come in line.
Oh, so that's another great way. So using, so there's a lot of ways to do this. So, and that maybe we do it the way we'll discuss today. First run, throw the data loggers in to verify. That I think would be great. I forgot we had those.
Difficult. What you were talking about, the load was changing so much, it was hard to get it.
Hard to see it. So anyway, we have a window coming up though in this fall where if we've got 55, 60 degree air, we can put our air handlers in full outside air. We need to be careful how fast we go to outside air, right? You don't want to open the outside air full up and then overpressurize the building and have things go, you know, yeah. So you know, do it slowly. But as we've got right now, our return air dampers are 100% open. We've got the outside air closed. This is also a good time to verify that your damper's fully closed for outside as we go into winter, right? So that we don't have any leakage of cold air in the wintertime. So we've let this stabilize for quite a while now. So what we want to do is, we've kind of identified a problem in the graphic. We want you guys to find a mixed air sensor, cooling or a heating coil discharge, and a cooling coil discharge sensor. Okay? So we don't know what's going on with this cooling coil discharge sensor, but we're going to go into the mixed air section of the air handler, look around there, and then we'll work our way forward. Okay? So before, yeah, go ahead and you can go to the back window or the back door. All right, so how many sensors do we have in here?
Looks like 6, 9.
Okay. So how many sensors does our card that is reading this area, how many does it think we have?
1.
Okay, why?
Because these are average.
So how do we average when we get an array? We do 3 by 3 or 2 by 2, right? Remember when we had our discussion, we talked about averaging, we needed to have the same number in series as we have in parallel. So that these 3 would be in series, these 3 are in series, and these 3 are in series, and then each of those areas are in parallel with each other. And equivalent, it looks like one big sensor, and it averages this space or this temperature. Okay. So right now we're reading 72.2 and 73 on this little guy. Which one of these are going to be more accurate?
The thermocouple.
So probably the thermocouple. Kind of depends on the style or who the manufacturer is there, what it's rated at. What is yours?
73.7.
So 73.7 there.
It's going down though.
Yeah, so it'll take a second.
So the flute could be accuracy of plus or minus 1 or 2 degrees, where the lollipop could be 3 to 4 degrees.
Okay. So then there's other thing to consider is that since I have 9 sensors in here, how accurate is 1 point? Okay. So because we're averaging, we should be pretty uniform with the way things are right now because we shut the outside air. Okay. But we're still averaging, so it's something to take into consideration. What about one of these guys?
Not bad.
So it says that pole is 73 even. I'm 72.3, 73 on that one.
73.4.
Okay, so they're all pretty close. Our lowest one was the thermocouple. Okay, now how can we verify one's more accurate than the other? It's kind of hard. You can use a water bath and check this in like ice water. When we checked this one in ice water, it was low. And I'm trying to remember if it was about 1 degree low, which would make sense because then it lines up with what we see on the others, right? So we'll check this one more time. It says 72.6 on that pole, 72.5 there. So again, the ice bath could be I was next to an ice cube, and that, you know, if it touches the ice cube, that's a little colder than the water. So for the most part, if you're within 1/2 degree, you probably don't need to calibrate, okay? Because you're going to have enough air in just the area that's covered by the sensors that a point sensor is not going to get you the accuracy you need. All right. we're more important is we want to make sure we're consistent all the way through our air handler. So if I'm 73 here, I should be 73 all the way through. I go through the air handlers or the fans, maybe I come up a little bit, 73 and a half. And if you're looking like that, it's beautiful, right? Just leave it and don't worry about it. When you get trouble, then we have those little data loggers, and that may be another really good way to verify it. So why do we want to do this? Why do we want to calibrate these sensors?
So you have better control on the building.
Okay, so it provides better control, and ultimately, instead of us lowering a set point, you know, like say we're reading a couple degrees off, we lowered our set point. We'd rather have the right temperature, and we'd also not want to put too cold of air down the duct, because then you just have to reheat it somehow, whether it's a reheat coil or hot deck to blow hot air in there. We have buildings that we have to run the hot deck all year round, right? And if we can minimize that or even shut it off in the summertime, that'll save us a lot of money. So making sure your system is calibrated, especially on the big equipment, right? Room sensors, we can get away with those. They don't really add up as much, but something like this does. So the last sensor or last measurement, 72.6, 72.6 on both of those, and then we're 74 on the little lollipop. Okay, pocket thermometer, and that one's 73.4. So, but could that be accurate?
Right there it could.
Sure. Because we're not in the same place, right? You could always take all of your sensors, put them right together, and then see how close they are, come up with an average, and then use that. Or pick one that you think will be the best. All right, let's go to the next area. So this is our first sensor right here.
So look again, do these drift over a period of time, a year, 10 years, 15?
They can. You can get some drift in these, but they don't usually go very much.
Does cleaning them help?
It will help so that you don't get moisture buildup in them. So if you get any type of moisture in like the fuzz that collects on them, blowing them off once in a while will help that. They'll make them last a little longer, but they usually don't drift much.
Okay. And then just real quick, something else to check on these sometimes, especially if they come through the air handler, if it's a negative pressure,
Oh, yeah.
and this is not sealed coming through, then you're pulling air from the outside of the air handler down the tube, and it's hitting the sensor and giving it a false reading. So you have to kind of look in there and maybe put some silicone or something to seal that off. I've seen that a lot.
Yeah, you'll see that in rooms sometimes where you'll get a positive pressure will push cold air from up above or hot air from up above down the wall into a stat, and it's always reading incorrectly because of it, especially on outside walls. All right, so we've identified our mixed air sensor. We should have had a preheat sensor or a heating coil discharge sensor and a cooling coil discharge sensor. So I want you guys to find those sensors. So you should have a heating coil discharge sensor and a cooling coil discharge sensor. Any guesses other than those that already know? Okay, so there are averaging sensors in here. What do they look like?
Got a big long tube.
But what does that look like? What other device looks like a freeze stat?
Yeah, that's
Okay.
what I was thinking. That's why I did say that.
So we do have averaging sensors that occasionally do have this capillary tube look to it, just like a freeze stat. The one that's over here on the wall, you can look at it, and the way you can tell is, for one, it has a little label on the top, but it also doesn't have a reset button. We'll look at the freeze stats, which are, where should a freeze stat be? On the upstream or the downstream side? So it's actually the downstream, because we want the coil to have a chance to do its job, right? And so in this case, this is a little bit of a weird one, right? We have these heaters up above that inject warm air into this area. What's going to happen if we turn these heaters on and we've got 30-degree air coming in?
Not be 30-degree air anymore.
Okay. What happens though with these fans? You got hot air coming off of them. Where's our cold air coming? From behind us?
They'll start pulling
What happens to hot and cold?
hot
It's
air
going through the
drop.
bottom, the hot's going through the top.
Yeah, so the hot air is going to stay pretty high, but the cold air is going to come down below because of the way that this is built. Okay. The one thing that this gives us is, or why would we do that? Why would we put this at the top? Or put in heaters like this as opposed to a big coil like what we see here? So if a fan is pulling air through a coil, what happens? What do we introduce to the system by pulling air through a coil? Static pressure, the resistance. So if I have a big coil sitting right here, and I'm not, or I'm not able to bypass that, then the fan all winter or all summer long is pulling and having to use energy to pull the air through that coil. By putting these up here, you eliminate that static pressure drop across the coil and save energy over the life of the fan. Okay. Now, this doesn't mix very well though, so it's a trade-off. This building's a pretty tight building, right, Brooke?
Oh yeah.
Okay, tight building, so we don't need as much outside air in the winter time, and so it works in the case of this building. If you had a really leaky building where you needed a lot of outside air, we may not have this work very well. Okay. All right, so we've got our sensor here. Where's our cooling coil discharge sensor? Where should that be? It should be on the other side. So actually we have two of these, right? So we got a sensor there, sensor here. All right.
Doesn't sense the top third.
Right. But what are we most concerned about here? Our cold air on the bottom, right? So really, if there'd have been room, it'd have been better to run a sensor all the way across here and then go up. But again, we're catching this heat a little. We have freeze stats, hopefully on the other side. We do. That'll catch it, and if it keeps it from going too cold. Okay. As far as our sensor, we're 73 on both of those. What's this going to be like when I shoot it against that tin? Okay, what happens with the reflection?
It's special though.
So right now I'm showing 72, 76, 73, there's 76 right there. And it had to do with the way it angles. So these kind of thermal guns are really good for kind of scanning an area to see if there's differences. They may not be the best for calibrating, especially if you have a shiny surface. Okay, if I do it on something that's not so shiny, we can do the pole. So that's saying 71.6, 71.4, and it doesn't seem to 71.6. So it's a little bit.
It's actually reading
71, 72, 85, 76.
it's actually reading the
Reflection.
reflection.
So yeah, a shiny surface with these doesn't work very well. Okay, let's go ahead and go in and find our cooling coil discharge sensor. All right, so take a minute and see if you can find the cooling coil discharge sensor. So on the coil, we've got 4 freeze stats, right? One high, one in the middle that kind of wraps to the bottom. So is our coil pretty protected? For the most part. I still would worry if we had a lot of outside air. We got kind of the bottom corners that don't really have freeze stat on them. And I'd rather see the upper ones a little lower. But in general, we should be pretty covered. Anybody see the discharge air sensor? Did anybody find about the $400 or $500 a year that's in here that we could save? There's $400 or $500 a year we could save in this plenum. Did you see it while you were looking around? Well, they're slow right now, but it's not that. So there's a way we can save it, and maybe it's $250, but somewhere between $250 and $500 a year. We'll have you look all around.
So if you have the sensors here, the discharge sensors, why not have it in the plenum?
We do have some out there.
Oh, you have some of that.
That's the final. But
so you have this. This is like the middle one. Okay.
So Gary, climb on that ladder and see if you can see our $200 to $500 savings. Okay, lean your head back just a little, Gary. Come back, lean this way a little. You feel anything?
Feel there. Oh, the air coming out.
Around the pipe?
Around the pipe there.
Oh, you can see it from down here.
You see it right there.
Yeah.
Like no insulation there.
No.
Hey, there's daylight.
Yeah, if we were to turn the light off, you could see that real easy.
That's a really, what he just said. If you go in an area like this in your buildings, you've got a light on one side, you turn this one off, and you see all kinds of holes that show up. You can walk off.
You can use it for outdoors.
Yeah, there's an air handler that was, I think it was in the Tanner building. Everything was good. Get on a ladder, there was a strip 3 to 4 inches across the top of the coils. It wasn't sealed. It was just leakage free over the top.
So there, if when these fans are, because right now we've got them down to 35%, they're normally running about 55%. You'll probably get anywhere from 200 to 300 CFM that'll leak through that.
Being pulled through.
I ran a quick calculation. It was about $250 to $300 a year in energy waste from that air coming through there. Just that one hole. So when you're in your buildings, how long has this been here? It's been 9 years or 10 years this building's been here running. Nobody ever saw that. When I was with the control company before, Atkinson, I was in here, we set this place up. I never noticed it. So it's keep an eye out for stuff like that, because in the long run, we can save a lot of money on this campus just by filling little holes like that. I mean, it really can make a difference. There's some down there.
It's a fire.
That feels warm.
There's some little holes here and there, but that's the biggie. Okay, did anyone find the discharge air for the cooling coil? Okay, so we have 2 that are outside, and those are the system discharge, but there's not a discharge sensor in here. So we found 2 on the other side. We're missing 1 here. There was only supposed to be 1 over there. So what happened? Okay, so the graphics got built by guys that never got into this area, right? And the temperature sensor looks right. You know, maybe it's a winter time. I'm 55 here, I'm 55 there. I got no heat on, or no, you know, everything looks good. And so the sensor was never physically verified. The installer put it on the wrong side. Maybe it was a coordination issue, who knows?
But it's actually needed though because of where the coils are.
It's probably better there. And what maybe happened is the decision was made to put it there because it was better, but the guys that did the graphics didn't get that info, and so it didn't get put right. So we'll fix the graphics, but that's one little thing that when you find something weird on a graphic that you're working with, let us know. Okay, Matt and Bob, who am I missing? Oh, that's 3 right now. Those things, we can fix those so that they're accurate, okay? All right, let's go back out here and then we'll talk about what we need to do to calibrate. Right, how do we identify, like if we're going to calibrate one and we want to make sure we identify which one we're calibrating, how do you do that? Other than Brooke, he knows. He's done this. Gary, what have you done in the past? You've done this plenty. You're going to calibrate one of your sensors.
See if my drawing's right, see if that's where the wires are actually going.
Okay, so use the drawings. We got a set of drawings here. We could pull those out. Look at that. So say I've got a sensor over here, and I've got 2 that we know one is one and one is the other, but we're not sure which one. So what's one of the techniques you can use?
Put one of them in a known temperature.
Say it.
You can put one of them in a known temperature.
Okay, so if I've got 2 and I know they're both in the mixed air, what can you do to one of them to differentiate it from the other? Unhook it. Okay, so we've got an easy one to get to. There's a ladder with happens to have a screwdriver there. So, Mike, you want to scoot that over and come on over here. So when he disconnects this, what should we see? So we've got a going purple. What else could it happen?
Or it'll go way out of, it'll go like 40 something.
Okay, so it'll go to some crazy number, either high or low number, right? So we're just going to disconnect one side of it. And Brooke, what do you see? Nothing yet.
Just still.
What is that scraping? Okay, what do you got?
Okay, so that's the one, that's the discharge.
So which discharge?
Just right after the control.
So it went to NAN, well, minus 140. If I mouse over it, it shows me which sensor it's tied to. So it's the heating coil discharge temp is the one that's mounted right there.
Oh, I was looking at what the graphic was, so.
That's our mixed air. Okay, so the heating coil, so you can go ahead and hook that back up. So one of the other things is you calibrate sensors. Sometimes it's good to check to make sure you've got the right one. Most of the time we don't have an issue, but for instance, we have 2 sensors out here on the discharge air. And if we calibrate one a little bit different than the other, we just need to make sure it's the right one. Okay. Typically, you'll add or subtract a slight offset from the sensor to get it to calibrate correctly. So on 2 of our buildings now, we have analytics. And we've done some analytics on several other buildings that are quite a bit more. But these are the Atkinson analytics that give us kind of a functional test of the system on a periodic basis. So the air handler, we're testing, I don't remember if it's once a week or once a month. We do just what we've done. We put it into a full return air, run it for 20 minutes or so, half hour, and then we check to see all the sensors and how close they are to each other. Then once they've done that, there's a report that comes, and if these lines are bright, that means that we were outside of the 2-degree margin that we set as our error. So if we're within 2 degrees all the way through, we say, yeah, we're pretty close, we're going to leave it alone. But if it's not, it lets us know that we have an error and that we need to probably go and look at those and calibrate them or verify what's going on. In the case here, we probably have a chiller still running when we think it's not, and the chilled water valve is not shutting. And that's probably what's causing our sensor issue. Okay, but that's one of the things that we can use analytics to find is make sure everything is working correctly. There are some other analytics down further where we look at, let's get this one back up. So boxes that have zero flow alerts. We tried to zero the box during the night, and if it didn't get to zero, then we put a little flag on it saying, hey, the box isn't closing. We do the same with the max heat and cooling and check those. And so it's kind of a list of things that, hey, here's the big issues in your building that if you've got a minute, go tackle these before somebody calls and complains. Okay? It's kind of a proactive approach of trying to find problems in a building. We have found places where we get areas that are overcooling because the damper doesn't shut. But maybe it's an IT closet that no one's in there. But we're at 55, 58 degrees, 60 degrees all the time when it doesn't need to be that cold. So we could be saving fan horsepower and cooling by fixing those problems. So it's one of the things that analytics helps us to find are some of those errors. So that's part of the reason we picked this building to kind of look at is because some of those things came out as we looked at this and we did a review a week ago. And so, any other questions about that? So thanks.
So you guys set this up, or Atkinson set it?
So Atkinson created the programming blocks for these two buildings and help us to implement them on these two. Now that we have the blocks, we can put these on other buildings and kind of do our own. So, and we'll get to that point eventually. Okay. All right, guys, that should do us.